globe, lads.
Been waiting patiently all day.
I'm sure they'll all pour in. They're snarling right now in the shadows, waiting.
Marlin in the shadows. Classic.
As long as they don't wait till we leave and then they come back in, right?
There you go. I grabbed Dr. Mike.
Stage?
No, we're good on the regular.
What's up, everybody? What up, Gio?
Yo, what's up?
Bees, tickles, what up?
Good stuff. Good stuff. Dr. Mike has been putting in the work. So is Alan. Got occlusion
Dude.
time with the videos synced up. It's looking great.
Heard we got a new observation tonight reveal, possibly. Whew.
Yeah.
82 miles, I heard, roughly. Give or take a globe.
Plus
Give or
minus
take
the
one globe.
To a one globe accuracy.
Yeah, it's accurate within one globe, guys.
1 AG, astronomical globe. Astronomical unit.
Yeah. Yeah, and AG is otherwise known as 3959. Ooh, we got a Celestial Theody debunk now, too. Nice. Debunked by a small hill, apparently. You're adorable, John.
Yo, where's the most recent PDF with all the new data somewhere?
I got
don't
you.
Have that one. Thank you. Is that not up on the database? No.
No, it's like fresh.
It's baby fresh.
Baby fresh. Here you go. Posted in live stream.
Thank you.
Debunk of the Pikes Peak data. Let's see what we got here.
You totally need to add in a slide in there. That you need to add that slide in with a list of all the coincidences. Right.
Oh my God! No way. Yo, your debunk of Pikes Peak data is no refraction. Or wait, what is your issue here? Visual angle from his house. Oh yeah, just doing it improperly. You debunked it. Hell yeah, nice. So no actual updated position. All right, Gio, you about ready, my good sir?
Yeah. Yep. All's good to go.
All right, sir. Rolling my intro. I'll be back in a minute, and then we will go live.
Sounds good. Yep, I got the screen share up.
All right, cool, beer Mark.
Oh, I like the first sentence. Defeat the Globers using their own tools.
Ain't it dandy?
Boy, does he.
That's one of my favorite things to do. Use their own stuff.
All right, hello and welcome everyone to the Celestial Theodolite Update and Overview Part 2. Tonight is going to be a little bit different from last week's episode. Tonight, before you participate, you're going to have to steelman. Tonight's pay to play. You have to steelman to participate if you're going to argue against it. If you have a question that you would like answered, that's totally fine. You don't have to steelman. But if you want to present argumentation and or debunks, you have to steelman to play the game. At least once. You don't have to agree with it. You just have to say the proper phraseology out loud one time, and then you can participate. Now, there are some people here that are gathered with several Google Docs, Google Drives, with quote-unquote debunks, and calling the Celestial Theodolite now a prank. If any of these people would like to participate, remember, all you have to do at any time is throw in a steelman, and we can engage in a fruitful conversation. This has been misrepresented, and it's too important and too easy. It's too simple, right, to let it be co-opted and misrepresented in the way that it has been. Our position, as always, is using plain trigonometry, just the difference in altitude between the observer and some mountain peak at any distance away, whatever distance it is that you're going to calculate, right? You'll get the corresponding angle, and then you can go into Stellarium, take that angle, go to the peak of that star, line up that angle. Go to the peak of that mountain, line up that angle, play out Stellarium until a star intersects at that angle. And then you can go out where you took your measurement from for your distance. You could watch that star get occluded at that same time. What does that mean, guys? What does it mean if I look through a theodolite and I measure it, and I measure a mountain peak at 219 degrees, but I measure a timing of an occlusion of a star based on an angle that's 231 at the same distance away that I would measure it at 219 with a theodolite? What's happening here, guys? What's happening here is a long claim from our side, is that when you're looking through a theodolite, when you're looking through any optical device and taking measurements, and they're not, and perspective, specifically curved visual space, isn't being accounted for, and all you're accounting for is quote unquote the globe and refraction, then the missing, that's what's in contention for what these measurements are when you're taking them, because you can't have a timing that shows a different Euclidean space than what is predicted on a globe of specific dimensions for an occlusion time. Now, we have two specific geometries here. We have the spatial field, which is Euclidean, straight lines. Things are where they are in three-dimensional space. And then we have the spatial field, which is where you perceive things. When things are close to you and you have other references, like, you know how far away this is in reference to that, the difference isn't that much. But when you're looking off miles and miles and miles into the distance, you have optical compression and refraction, actual effects, and that is what's making all these measurements appear that they're, why is it lower than expected? Why is 200 feet missing? Blah, 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 right? These are optical effects. This is what we've been saying the whole time. And we have this occlusion that corresponds to the almanac true position of the star, that when it intersects at that same exact angle at that time, you stop being able to see it on the ground. It shows that there is a deviation from the Euclidean field and the spatial field. I'm sorry, the spatial field, which is Euclidean, and the visual field, which is non-Euclidean, specifically hyperbolic. Now, you can take any mountain peak from any distance, do your calculation, get your angle, find a star that'll pass through at that time, and you can watch from your position, using the mountain peak as the crosshair to intersect that star. You will see it get occluded at that time that corresponds to that specific angle, meaning that the actual geometric calculated angle based off of plane trigonometry, meaning the full elevation, none of it missing, will be the correct angle to occlude that star at that specific time. So if you see it at that time, although you're not actually measuring this angle right here at the bottom right, this 231, right? You'll never measure that optically, I don't think, right? Especially not with a new, with the modern stuff. Maybe with an old one, we'll hear a little bit about that later. But you're not going to make that measurement 231 optically. But we're using the timing, right? The physical time that this was obstructed by this physical object here to make our measurement. And that corresponds to 231, which is the raw planar calculation, showing that the true geometry of this place is planar everywhere. You can calculate this at any distance. You just have to do it, for each individual thing. And actually, we have some new measurements that just came in that we're going to go over real quick. So the last time we spoke, a big point of contention was that Pikes Peak was an anomaly. Pikes Peak was Mike backwards engineering the data, right? We heard these speculations and, you know, just pretty much slander to try and make it, you know, and then we heard, oh, well, I don't trust the Pikes, I don't trust the Blodgett Peak data. I don't trust the blah, blah, blah data. There's something wrong with it. There's an anomaly. Guys, the anomaly was daylight savings time. You just set it back an hour and then the corresponding angle, poof, the angle's back. It's fine. So that was the big thing that we couldn't get anyone to tell us specifically what was wrong. Just that the data was anomalous, and I think there was guys. It was daylight savings time. It's fine. So we have Pikes Peak, Blodgett Peak, Cheyenne Mountain, Mount Rosa, Blue Mountain, and Green Mountain, and now added Greenhorn Mountain at 83 miles away, which we'll go over here in a minute. We went through and looked up all of these at the proper location, at the mountain peaks that they were at, based off of, and then the angle that the star would be at, based on what the angle would be, the calculated angle of the mountain relative to the observer who was doing the calculation, right? And then they all lined up all the way out to I think Mount Rosa was the last one we had there. Yeah, Mount Rosa, I think. Yeah. So if anyone would like to contest this data or propose their own globe, theodolite, or whatever, guys, now's the time to participate. All you have to do is just tell us exactly the procedure and the implication of what is being measured here when the occlusion timing matches the planar prediction for the imposed geometry to cause the occlusion.
Wait, you're saying the same set of circumstances is true for each one of these other observations? They're all confirming the timing that would coincide with planar trait calculations only?
Mm-hmm.
And how many are there? 13? 14?
Ooh, I mean, there's like 1, 2, 3, 4, 5, 6, 7 different locations now.
Okay.
And just Pikes Peak alone has like 17
It's just a
occlusions.
coincidence. It's just a
See.
coincidence, right? Oh.
So we have to go to like a 47 occurrence coincidence at this point, or it's 40x times, I guess?
I mean, you know, 10 to the 47, dude. It happens. It's an anomaly.
How does it
Guys.
perform as a function of elevation angle? So if you were to take any one of these observations and move towards your crosshair, go from 2 degrees to say 30 degrees, does the prediction still work?
Once you recalculate it from your newest position, it would work up into a certain point. The issue would
It doesn't
be
work, not would it, does it? Have you got
But
data to show it does?
first of all, don't interrupt me. I'm telling you how it would work. It's based off of timing. Once you have an angle where the difference in the timing between the globe and the flat Earth prediction is like less than a second, that's when you would have the most issues. That's the answer to your question. You would just recalculate it at your new distance because you're going to have a new corresponding angle to the mountain, and it should work just fine.
You're basically lengthening the triangle. I mean,
Because
it's a
you
weird
know
question.
the reason this
Wouldn't be
works
triangle.
is Stellarium we never entered any distance to Stellarium. We only went to a mountain peak with an angle that we calculated. Stellarium doesn't know our position. You could do this from anywhere, and the corresponding angle would line up. And we would love it if more people would go and do this to help substantiate that claim. We got Jesse. He's going to go out and take a measurement in, I believe, June or May, if I'm not mistaken.
I have a question.
Fire away.
So basically, is it, maybe Dr. Mike can answer this as well. Does it seem that the further away the mountain and the lower to the horizon the angle is, the more of a timing prediction difference there will be between globe and plane?
I would say so, but Dr. Mike?
I would think that would be true. The bigger you can make the difference, the more obvious it is. So, and that's why last night I shot one that was 82 miles away.
Nice.
Dude, 82 miler, high score.
High score.
High score. Let's see what we got here, boys.
I have a question.
Highest so far.
What's up?
Sorry, I have a question too.
Shoot.
So a few questions. Maybe I'll just start with this one. It occurred to me that I'm going to try to do a shoot myself of a low altitude peak, actually a smokestack at a distance of about a mile at sea level. And I think the nice thing about doing, as I call it, a small nearby hill, is that we agree completely on the theoretical altitude of the peak. The globe is flat on a scale of 1 mile, and there's no significant terrestrial refraction on a scale of a mile. So you just calculate the geometric elevation angle of that smokestack, and globe earthers and flat earthers, I think, will agree on everything. And then we simply do the method, we do the sighting, we calculate, we do the sighting, do the occlusion, we transport ourselves to the top of the smokestack, which essentially is the same thing as the original observation point anyway. And we then compare the calculated elevation angle of the smokestack to the geometric position of the star as reported by Stellarium. That's the flat Earth celestial theodolite method. And I think if you think about how that's going to work out, I think you'll see that there's a little bit of a problem. I don't know if you can think about that this quickly, but and maybe it's just a question for the next time. I do have other questions, but I'll save them until later.
What's your big mystery problem, Guy?
You mean with that?
No, I mean the other thing that you weren't talking about for 3 minutes.
Oh, okay. Well, so another thing I think is worth wondering about a little bit.
John,
yeah,
ask you a question.
Oh, I'm sorry. I thought you were asking me to ask my question. Sorry, what did you say? I'm sorry.
You alluded to a point to your 1 mile proposal smokestack.
Oh, okay. Yeah.
What is it?
Well, the point is that so everybody will agree on the visual elevation angle, on the geometric elevation angle, because there's no globe curvature and there's no refraction to speak of. You simply calculate arctangent of the height of the smokestack above you, divided by the distance of the smokestack, and everybody will get the same answer. We'll all agree on all visual and geometric angles to the smokestack. Refraction isn't an issue. Agreed?
Yeah, sure.
How's that relevant though?
But if you're calculating something where the difference between the two isn't that much, though, then it doesn't show anything.
No, but that's what I'm saying is that then what the globe Earth CT method would then be to say find the occlusion time, look at the visual elevation of the star from the observation point, and see if you get the same thing. And then
also though, real quick though, we're also only referencing the true position anyway, so we're not even referencing the visual. So it doesn't matter either way.
Right, I get that. So what you guys would do would be to transport yourself to where your crosshairs are on your 1 mile long theodolite at the top of the smokestack, and then you would ask Stellarium to tell you what the geometric elevation of the star is. From the top of the smokestack. And I'm telling you that what you will find, because I'm at sea level, if that smokestack is down at 1 degree or 2 degrees, you'll find that the geometric location of that star is 20 to 25 arc minutes lower than the visual elevation of the smokestack.
Dude,
which is
that took so long to get there.
Which is the same as the geometric.
Jesus, it took so long to get there.
Sorry.
Bro. Negative coordinates. Yeah, negative coordinates isn't an issue for us. If our position is that we see in a hemisphere of a radius of, I don't know, let's say 39, 59, and if you were to map that out, you would have positive for the north, negative for the south, and you would merge those two hemispheres. So when something's out of your field of vision and it's set into the horizon, right, it's set into your field of vision. If that's the case, then you would map that mathematically the same. So the negative coordinates isn't where the star isn't, is it beneath my feet or is it above me, but just out of my field of view, would be mathematically mapped the same. So the negative coordinate that took you so long to get to, this big, dude, were you holding on to that all day, John?
No, dude, actually, I haven't.
You're so far behind, it's insane. What's your next one, big guy?
Well, actually, it's interesting. It's interesting that you mentioned negative coordinates because nothing in what I said had anything to do with negative coordinates. I understand you're in a hurry to get to another question I have, but I haven't asked that question yet.
You said it would be 20 degrees lower than the horizon, didn't you?
No, I said it would be 20 degrees. It would be 20 to 25 arc minutes lower than the visual elevation of the smokestack, which is the same as the geometric elevation of the smokestack.
Got you. I did misunderstand that. I thought you said below the thing because I saw the message you sent earlier about the sun being below the horizon or, in negative coordinates. I thought that's what you were alluding to.
I know you did.
Yeah, so that wouldn't line up then. Yeah, you're right.
So I put there's a write-up of this thing, if that wasn't easy enough. And it could be. I mean, you have to think about it a little bit, but I put a write-up called A Small Nearby Hill, And I think it's it's in the chat there. You can look at it and see. But I think it's a real problem because you are going to find that your method has about a 20-25 arc minute difference.
I have a question though. I have a
Wait,
question.
yeah, go ahead.
Why? Okay. So you're going to use a smokestack that's 1 mile away,
It's gonna
and
be so small.
it's going to be like a tiny angle because I'm assuming the smokestack's not that high, so it's going to be a very, very, very small angle. But also, just in terms of raw inclination change across physical space, there would be less than an arc minute of difference in terms of the globular prediction just from one position to the next, right? Because you're only traveling 1 mile, so that's like, what, 50-something arc seconds? And then from that less than an arc minute difference, then you have to incorporate the difference out of that arc minute, the percentage of difference out of that due to the deviation from a globe to a flat plane. And across 1 mile, it's only, what, 8 inches? So you're going to take the effect of 8 inches on an angle of less than an arc minute to get the resulting differential angle. So I feel like that's going to not even be useful, even if you were able to measure it.
Well, I think you maybe didn't hear me say that that's what I like about this example, is that we will all agree on the visual elevation of the smokestack, the geometric elevation of the smokestack, because refraction, terrestrial refraction and globe curvature simply aren't operative. On a scale of 1 mile, there's no terrestrial refraction to speak of, and there's no globe curvature to speak of. So the only thing that makes a difference is the very large difference between the visual elevation of a star and its geometric true position, which is what your method relies on.
Yeah, but I think that when you have a baseline that's only 1 mile and an angle that's like really low, the deviation in, let's say like the deviation in that angle in terms of a percent, right? Like let's say that the angle is, I don't know, like half a degree because it's a smokestack and it's 1 mile. So you get like a half a degree angle and it's 1 mile away. So in terms of half a degree, the amount of deviation is going to be like a tiny percentage of that. You're going to have to be so precise because with that, imagine your lever arm. If you take a lever arm and on the close end, you change its distance by, a small amount. If you extend that lever arm from 1 mile to 80 miles, now the other end of the lever arm is like way, way more off than it was at 1 mile. So that's what I'm saying is I think that even if you were to do this, the precision that would be necessary in order to try to like draw out any kind of meaningful conclusion would be beyond that which you're able to achieve with your instrumentation.
Well, I invite anybody who's capable of actually doing the arctangents, right, and then thinking about and doing the stellarium, understanding what stellarium does, just to think about it. I put the write-up there, and you can think about it yourself. The particular smokestack I'm keying on is one near my beach place. There's a road that I can view it from about a mile away, and it's 240 feet tall. That makes an angle of about, I can't remember, but something like 1.5 degrees. It's more than 1 degree. So it's kind of perfectly placed. I think the geometric angle to the star will be maybe a little less than a degree, and the geometric elevation of the smokestack will be about 1.5 degrees, degree 20. I'm not remembering exactly now, but there'll be a very large difference, a 20 to 25 arc minute difference in the elevation of the geometric elevation of the smokestack and the geometric elevation of the star from the smokestack.
It sounds like you're basically trying to turn it into just like a regular theodolite and rely upon a visual angle again.
Yeah, he's basically trying to change it up
exactly,
completely.
dude.
Let's do something different.
Yeah, the only way to rectify it is to break it into input. Like that's actually it. That's crazy, dude.
Way to argue against it is to create an argument that it's not in the form of, I don't know what you call that, a straw man, and then argue against that avidly, and that's the best way that you argue against it.
A tiny straw man, though. Right, like a smaller straw man.
I'm happy to move on to something else if you want, but I just invite, especially Dr. Mike, because I know he knows how to do the calculations. I invite him to take a look at my thing and think about it.
We'll see. The thing is, though, we just thought about it, though, and it's a misappropriation of the ratios needed to make a meaningful substantiation. So it's cool that you're trying to do this and now presenting it as a debunk / it's not a valid method. You've defeated it, but you haven't done that at all, right? It was a good try. You can try again.
I just don't understand why would you only do it like a mile away? Like, isn't the point of getting further away to make the difference between the globe and the flat? Like,
because then he has to rely on the visual angle again. He just made it into a regular theodolite.
No, it's not that at all. The point is to try to eliminate the globe and refraction terrestrial measurements.
The purpose here isn't to eliminate the globe.
No, that's the point. That's why I thought of it.
1 second. Well, you thought of a way to eliminate the globe. That doesn't even make sense. The method is to tell the difference between the globe and a flat Earth. You've proposed a scenario where it would be indistinguishable. And so that's not...
Right. So I understand what you're saying. The point is that, of course, because it's close and nearby, we will all agree on the visual and geometric elevations of the... Hold on. I'm almost done. We will agree on that. And then my point is
so there's this thing, though, John.
Can I finish?
Where you'll like start repeating everything really slowly again that we already agree upon. And I do not have the patience to do that with you on every single point.
Okay, well, I just have one more question, and I'm going to have to leave pretty soon. But it's okay. I don't even have to ask it. If you're ready, I'll ask it.
Go ahead.
Yeah, so this is the question you're anticipating, Ellen, which is that when at the time, and I'm sure Mike knows this, at the time that he observed 39 Aquarii being occluded by Pikes Peak, at that same time, Stellarium reported that from the top of Pikes Peak and from his house, the true angle to the sun was negative, was below the horizon. The sun. Can I just finish? So the sun was below the horizon. And the interesting thing, of course, is that now that we've kind of embraced Stellarium, it is the case that if you just pick any celestial object at random and ask Stellarium, what direction do I have to look to see the geometric object, assuming I could actually see it in that direction, there's a 50% probability that's going to tell you have to look down between your legs, down toward the ground, because half of those objects are underneath your flat Earth.
Didn't you just address it, Alan?
John, you sweet baby boy. We already addressed that one.
I love how he gets visual. Do you get visual confirmation of that when you're looking at the ground?
Long as I get to say it again, really
look right down.
Look right down through the ground. All right, man. Is there any other actual refutations other than using a distance where it's indistinguishable and doesn't matter, and or saying, negative coordinates definitely means that the Earth is a globe, even though you would plot it the same if it's still above the horizon and you just see it go out of your field of view? Is there any other
steel man at first, right, to even qualify?
Dude, I know you like how they slid in with that. With I just got a little baby question for you. But it's John though. We got to let him do it because he's literally the only one that's available, that's competent enough on the globular side to even try and co-opt it / refute it. So he's actually putting in the most amount of work for the globularist right now. So mad respect.
The fact that he steals man it so effectively and then goes on to ignore all the key components is quite mystifying.
So we should be able to effectively use this to do celestial navigation, right? We should be able to use the same logic.
What are you talking about, bro?
Not even relevant. I'm not talking about celestial navigation.
This is reverse celestial navigation, effectively, right? Taking our position and working out where something will be. So we can do the reverse, I guess, and we can say, right, knowing this relationship you've established, we should be able to apply that logic and work out a position from a stellarium predicted angle.
Not really.
In time of occlusion.
I mean, it would be so convoluted. I think
you can do it in software. Use one of the libraries that's got all of the database of objects and.
I mean, technically,
directed angles.
Well, technically, Mike already did that, right? So, if you take his different mountain peaks that he did, they're all starting from the same spot. I'm pretty sure, right, from his house. So that technically would have already been done, but it's a measurement at a specific time, so it wouldn't really do you any good to triangulate in the way that you're probably thinking about, because you would probably want to triangulate it quote for cell nav for practical purposes, right? You want to do it on the same night, right? I don't think this would really work that way.
Same position. You don't need to be the same time. You can do it just from the same position.
Well, you'd have to do it over different days for different stars to line up at different times.
That'd work fine.
I mean,
I would referencing the almanac position of the true position of a star and then correcting based on sight optics and dip angles. How would that be different than the current method?
No, you don't have to use dip angles. You just use your triangle here and work out the baseline that you expect to be on. Draw a circle. Well, you haven't got a map, but you'd have to use the globe map, obviously. But you would be able to say, right?
Jesus Christ, Dazza. You mean we'd have to use the graticule? Buddy, buddy, get Dazza. I expect more from you than this. You're the ECI to ECEF man. You're better than this.
They're both rectangular.
expect to be dazzled.
Don't need a graticule because they represent geometric forms. But yeah, so what I'm saying is that if you were to observe an occlusion at a peak and identify the star, record the time, you could then get a distance from that peak from where you were. If you happen to have peaks all around you, which sounds like Dr. Heffron does, you could then reverse engineer those distances to find a location.
What? Are you talking about?
You need to know
nutshell,
listen, to calculate the angle, you need to know the distance. Like that's what I was saying. What you're doing is like convoluted and not worth doing it.
So, but if I know
because it's retarded. Real quick, can you steelman what the
this
celestial theodolite is real quick before we
Can
continue?
you steelman it? Let's go.
Can you just steelman it real quick before we continue?
Yeah, so you have a location, you measure the angle, you'll calculate the flat Earth angle to the elevation point, find a star in stellarium that will be occluded at that elevation angle, and you look up the time, and that time tells you that you've your ducks lined up. To be honest, I don't fully understand why it works, or even if it works in all cases. Because we're picking very low elevation angles. That's my understanding of the process, but I can't tell you why it works. But all I can tell you is that process you go through appears to be allowed to correctly deduce the occlusion angle to some precision.
Awesome. It allows us to deduce the timing specifically based off of the angle that the mountain calculated, like how big it would be at your distance to it. So the significance of like why it works at that time is because the Earth is flat.
Right.
Although it doesn't read any actually observed angles. So that's the thing, right?
Yeah, it predicts when you're not going to see the star because it's blocked by a physical obstruction that has a specific elevation angle that's different from the globular prediction, therefore a different timing in which it would be occluded. So the thing about this, the reason that like John, for example, is like trying to co-op / destroy the measurements is because the only one timing has been measured thus far, and it's always the flat Earth elevation angle. It's always the timing that happens quicker than the globe because the star gets occluded faster than what's expected. Based on the elevation angle, because when you calculate it, stellarium doesn't know where you're at, so the timing it shouldn't matter, right? If it's on a globe at those distances at that angle, then it has to be at that timing if it's physically there, unless it's at a different time because it's physically higher because it's not tilted away from you. That's what this shows. That's why it works. It's showing that the Earth is planar with respect to the stars.
I'm not convinced of that, but I'll still say that it should be relatively straightforward to turn it into a reverse exercise.
That was a good steelman, though.
And
by the way,
calculate the position from a predicted time.
Yeah, and quick note. Quick note on the position of where you do the calculation. It's on the peak of the mountain. I'm not sure if you mentioned that on the thing.
Yeah.
Like other than that, nailed it.
Angle from stellarium.
Well, you calculate both angles, right? You calculate the flat and you calculate the globe, and you see which one gets occluded at. Each correspond to a time. You make the observation, which time is accurate, and it turns out for this observation and for these 14 to 17 others for all these various peaks, it's the flat Earth straight elevation angle prediction that works every time. That's why
every time.
And that process you just described, Shane, will work in reverse. That if I see an occlusion, write down the time, look up the star, I can back calculate the baseline on the flat Earth.
Yeah, I mean, if you're just looking at the mountain peak and you don't know what star just got occluded, you just time it, boom, look in stellarium at that exact same time, and then you can figure out what star was just occluded. Yeah, you can do that.
Use the angle and
that's actually what this entire table does.
Right. It's exactly what we did, right, Dr. Mike? You just chilled and watched all these stars get occluded, marked down the time when each star got occluded, and then basically went into stellarium, was like, oh, it was this star. Oh, it was that star, right?
That's it.
Yeah. It's pretty cool. It's so solid. It's so solid. Like, I haven't heard any good refutations.
Yeah, like I said before, I'd be really keen to see how it scales with elevation angle, because this shouldn't have any issues, right? If it is a flat plane, eventually you're going to have to deal with refraction differently, but if it is a flat plane, then it should scale with elevation angle.
To a point, yeah.
Why to a point?
Well, because then it's going to be indistinguishable between the two, like we just went over with John.
Yeah, because the distance is short, but it should still work, right?
Depending on the distance and the angle, yeah. It's a ratio that has...
Depending on the distance and the angle.
What do you do?
A straight geometric thing.
Oh, man. Because there'll be a point when they're too close and overlapping, and we won't be able to distinguish the difference between the two.
Yeah, that's why the
I'm not
farther
saying
away you
distinguish between the two. I'm saying
Well, that's
come
the
up with
point
the
of this.
correct angle on the
Jesus,
ground.
that's why. Oh my god. Okay, yeah, Dazza, you yes.
But Deza, you do realize that the reason why the distances are so long is so it accentuates the differences between globe math and flat Earth math. That's
I
the
haven't
point.
seen a fully worked globe solution yet.
Well, now's your chance. Here's the data.
This is your moment.
This is your moment.
Look, Kelly
The other question I
Clarkson.
had about the table is you've
What's
got average elevation or something, you say? Official altitude and average altitude. What are those things?
I'll jump in since this is a recent addition. Official altitude is what the city near the peak claims is the altitude of the peak. The average altitude is the average of all the actual measurements, which is the distance to the peak times the true elevation of the occluded star at the time it was occluded. And then that calculates what the altitude of the peak appears to be. And then the flat delta altitude column indicates how far that deviates from what a flat Earth would predict. The d squared over 2r, that's the standard obscured portion of the peak. And then when you look at the difference between those, that's how far the actual measurement deviates from what the globe model would predict. So in all cases, the globe model is way off from what's actually measured using this method.
Yeah,
And
look at
then
that Greenhorn
Sorry,
Mountain.
I misunderstood that very first bit. The average altitude. The average of what again? What
it's
measurements?
the average of all the measurements below it for that mountain.
Oh, okay.
So in this case, Greenhorn Mountain has two measurements, 3456 and 3865, and the average of those is 3660. And by that first measurement for HD 35182, that one actually hit a little left of the peak, and that's why it's 300 meters low. That the quality of that video is so bad it was hard to tell it wasn't quite hitting on the peak. I just left it there to emphasize that it doesn't know what the real altitude is. And even with that, obviously the globe Earth prediction is it should be 1372 meters lower, whereas it measured almost identical to the official altitude.
How was it measured? Sorry.
That's mentioned at the top of the document. The altitude of the peak is the altitude of the observer plus the distance to the peak times the tangent of the true elevation of the occluded star.
Oh, yeah, so
that's it.
Yeah. Sorry, I thought you actually measured the angle or something. That's my misunderstanding.
It's measured using the celestial theodolite.
That's calculated. You haven't actually measured.
Oh
the
my
angle.
God, Dazza! It's measured with
It's
timing,
important,
bro.
right?
It's
yes,
measured with the time.
That's why it's measured with the time. That's why it is super important. Yes, agreed.
Yep,
That's why it's measured with time.
You just failed your steelman if you don't realize that the true elevation of the occluded star is the readout of the actual elevation.
Yeah, the whole argument is
That's
the
okay.
conceptual.
I thought you'd use your theodolite to actually measure an angle and calculate the elevation. So, yeah.
He did. He used the celestial one, and it comes with a clock that tells you the necessary corresponding angle to cause a physical obstruction. It's the most fascinating thing ever. It's all the craze and buzz. All the retired CIA employed people are trying to co-opt it. It's awesome. Allegedly, I'm just messing around.
It is pretty wild that like literally all of these peaks, it's just coincidentally flat math. Holy crap!
So as long as you can see a peak, anyone who can see that peak can use Delirium and find that same. So it's occluded at the same time for everyone who can see that peak. That's the craziest part because Delirium has no idea where the observer is. Yeah.
Right.
No, it's only occluded for the observer. It's not occluded for everybody, Shane.
At that distance, though.
You have to be in a direct line.
Yeah,
that baseline.
a triangle, a nice good old triangle. Yeah, exactly.
Yeah.
You got it.
So you have to effectively know where you are for this to make sense, even though you don't tell Stellarium. You're effectively telling Stellarium by looking up the angle.
Well, or you could measure, or you could just watch stars get occluded and then backwards derive it, like we talked about earlier, which you could also do with a spreadsheet.
But if Dr. Mike lived 100 kilometers away, then you could still see the mountain on a great day or whatever, and make the same observation. Use the same stellarium data to put in the same long lat without deviation to get the same angle, right? So any observer at that distance or any distance that you can see the mountain is a viable method. That's why stellarium doesn't know where the observer is. You keep trying to say that it does, right? Because you need it to for the refraction from that other position to make any sort of sense thematically or otherwise. So that's why it's important, right? Because it's completely removed, and you guys need it to be back.
You know what's funny, Shane? We've come a long way from Jeremy saying like, "Oh, you're saying I could shoot straight line to stars?" Yeah, with the celestial theodolite. Yes, you can.
What's everyone's type of theodolite? Mine's the celestial one because it eliminates refraction and shows the true elevation angle.
I like that one.
Dude, I still don't.
Go ahead.
Yo, I still don't think you can. You guys are getting triangles. What's the height of the star then?
911. Height of this. Well, technically, the height of the star would be 6210. You could treat it as that, but it's technically irrelevant. But for all intents and purposes, we could treat it as 6210.
Kilometers. So you're getting heights to stars with this?
No, that's the height that makes the radicule work. That's what makes CellNav work. When they talk about the celestial sphere, that's an equidistant web that sets the stars all at the same distance. Well, everything in the sky technically at the same distance, which is 6210 would be like the maximum limit of that. So when they're doing cosines to stars and all that, that's what they're setting it to, 6210. That's what it would be.
That's interesting.
That's the maximum, yeah.
Yep.
It's crazy how it's all coming together now.
The actual elevation to the star doesn't matter. We could just imagine an imaginary straight line that goes on to however far it needs to be to hit the star. But the important part is that like the intersecting or the time that it gets blocked, like that intersection would complete said triangle, said imaginary triangle, right?
Yep.
At that time.
And the farther away you are,
but
the more globe slant should be there, but it's not.
Yeah.
Yeah, but if we're drawing straight lines to stars, you should be able to get a triangle off it and get the elevation.
Yep. Well, I mean, he just said it, 6210. If you want to take it that far, you don't. I mean, that's not really the point, though.
Well, I know it's not the point, but still, if we got a triangle, we might as well use it. Use it all the way.
No. It's not going to be a physically meaningful altitude for the star. That's the same mistake that they all did. That's the same. That's what. No. Nope.
Any other questions or about how this works or anything like that from anyone?
Are we drawing straight lines to the stars?
No, Jeremy, like I see what you're doing. Like I get you. It'll definitely give you a calculative value, right? But I'm telling you, it's not going to be the physical elevation of the star.
Yeah, it's like a calculated potential altitude, but without being able to tangibly validate it. It's really it's the observation.
We'll never know, right?
But what we do know is that the ground's not curving away from us.
That is the important part.
Right.
Is that with respect to the stars, the Earth is measured planar. How is it measured, doth thou asketh? Well, first you take a calculation of the difference in your altitude between you and a mountain peak, and that will give you an angle. Then you find a star when you're on top of said mountain peak, and you look up at that same angle, and then you get you a stopwatch or cell phone or whatever has a clock on it, and then you measure the time that you can no longer see that star, and that is how you use the celestial theodolite to measure the planar geometry of the Earth with respect to the stars, because that specific time corresponds to a specific calculated elevation angle for the mountain, which is different than the globular prediction. Thus, two different timings will be produced from these calculations, and only one of them shall's to be measuredeth. And it's always the flat Earth one. Guys, it's never been the globe one. All right. So, are there any other questions? Any other questions, comments, or concerns? This is like, a substantial measurement of flatness here, lads and ladettes, that we could reproduce at different locations and really just hammer it home. The best they could do right now, obfuscate, try and make the measurements theirs.
But I could aggressively strawman it and try my hardest to make it about the difference in optic elevation angle between the observer and the house. Can I do that though? I can definitely. I can try to make it all about that. If you extend the theodolite to the mountaintop, as is the conceptual celestial theodolite application, then there is no reason to accommodate for any so-called optical displacement, right? Because we're not concerned with where anything appears to be. We're only concerned with where it is via timing and physical occlusion, and that always matches the plane trig math. That's it, basically, right?
The raw plane triggy. Don't be dissuaded by fake trigonometry or whatever Jesse was doing.
But we're like, oh, but the refraction can change the time at which it's occluded. That's absolutely true, which is why the globe prediction on the mathematical side includes that celestial refraction correction. Otherwise, it wouldn't be globe, right? That's the whole point, and that's the difference. And it's funny because back when they were actually refuting it, people like Ruhe for doing the math on the globe side, and every mathematical solution required bringing that specific celestial refraction correction back into play some which way, any which way you could, right? That difference over there on the right that you're looking at, that is the globe celestial refraction prediction for this observation. Any solution they had was like, okay, on the back end, we're going to move half of this correction back in. We're going to add it back in over here. We're going to bring it, because without that so-called different occlusion time induced by globe refraction, then there is no evidence of globe. It's all flat Earth elevation angles with, the refraction with every correction coming up globe.
A minute. Did you say the difference between these two is globe slant, which is made up in explicitly refraction?
Right. Exactly. Yeah.
Oh no. Dude, did they tell us that the Earth measures globe because we looked through a theodolite and we saw things weren't the same size, that didn't follow like the angular or the linear angular size formula? And we just determined that it must be a globe based on that?
Yeah, same logic, yeah.
Oh, no. Dude. Oh, that's unfortunate. Anyway, guys, we're here to correct that. Turns out you can measure the difference between the visual field and the spatial field by using the raw calculated elevation angle of a mountain peak and using that raw calculated angle to correspond to a celestial object in the sky that's going to intersect with it at a specific time relative to your location which you did your calculation for to get the angle in the first place. And if that star or celestial body stops being visible at that same time, well, guess what, lads and ladettes? You've just made a successful measurement of flatness with respect to the stars. The best kind of measurement, right? Not just saying it measures
one that's
flat,
repeatedly corroborated, yeah.
Because it also measures globe, right? But with respect to what? Well, with respect to the stars, the most powerful claim to anything, because it's our only external reference to measure the Earth with respect to something anyway. So we might as well swoop up the old celestial sky.
I don't think they can ever measure globe. They can only ever calculate it, right? Because everything you measure comes up flat with flat Earth elevation angles. You can only ever backwards calculate globe.
You can only backwards calculate what it would be if there wasn't an intersecting mountain peak with a flat Earth elevation angle to block it. That's the only way.
What'd you say, Daza?
He brought up GPS like very confidently, as if we don't have all the orbits on deck. They measured it. They measured at a globe with GPS. Go on, Daza.
Yeah, but it'd be cool when you guys develop this model to the point where you can predict the actual visual angle as well as your spatial one.
Oh, you mean the thing that's apparent and changes for everyone? No thanks. We're just going to use the timing intersecting with a raw flat Earth calculation angle, showing that the mountain has never deviated away from us.
Every time, Alan, it's fine.
Yeah. Oh, I do though. If you're going to chime in every time and talk about something that's retarded, I certainly do. Just to hammer it home so everyone knows, right? Because it's like, oh, it measured with GPS. We threw up GPS. Would you like to see GPS orbits? Do we need to stop the celestial theodolite Prezi to go over circumpolar longitudinal orbits? No.
Well, you remember, Alan, Daza had in his back pocket from Mordwand, when we're going to do the maps debate, that he's going to pretend the maps measure sphere because raw ECEF uncorrected data, which is laid on an ellipsoid model as surface normal, would show the Z coordinate with a height altitude, referencing that reference ellipsoid. That was going to be his big 1-2 punch, but because it's not doing it, he's just trying to whip it out. So it's up to you whether you want to go into all that.
Rather just stick to the celestial theory.
That defines your surface. That's fine.
It'll be okay.
Geometry is independent of the coordinate system, but I don't want to derail this.
Yeah, taking line of sight measurements with light definitely shows it's a globe. All right.
Absolutely does.
Any other refutations or questions?
Any other straw man?
Anybody?
You want to create a new straw man? Want to be creative with it?
Looks like.
Find
Gio, you got any questions?
If you explicitly state about how they have to bring that angle back, they're much less willing to venture ideas about how you can bring that angle back, I guess, right? If you call it out specifically, because this is what you have to do to argue it, right? Which is why it's our position.
I don't know if Gio's still there. Gio, you still there?
Yo, yeah. What's up?
Give a nice steel man of the celestial theodolite. I want to hear it.
What I was going to say about it, I mean, I could do that, but I was going to say what's cool about it is that it's using the ground. You know, people always talk about like, you can't prove the sky with the ground. And in one way that, there's something to that, but I think that's also like there's nuances to that. But this is actually using the ground in alignment with the sky. So that's one thing that really sticks out to me. Yeah, that's so cool.
That's what I like the most about it, because especially when Mike proposed the null hypothesis line of argumentation for us about, specifically like you can't use objects in the sky to tell you what shape the ground is, but you can tell what shape it isn't, right? So you could falsify one of these positions, but you can't prove it, right? So you go through a series of mutually exclusive proofs, etc., and you either falsify or verify or fail to falsify your hypothesis rather, and then you go from there. And then so with this, it's like he proposed the keep it simple, stupid, right? It's like the Earth is flat, the Earth is a globe, right? If the Earth is a globe, the star is going to get occluded at a later time because it has to get lower in the horizon because globe, right? Because globe makes lower elevation angle for peak because globe, right? And then flat is it gets occluded faster because it's not globe, so it's the mountain's just higher because not globe, right? Very, very simple, straightforward. And the only timing that's ever been measured thus far is the raw flat Earth calculation. It was flat, I think. I don't know.
Could you even take it further and imply that it's almost like they made the graticule with plane geometry?
I mean, that's certainly what they did, because that's how it works. When they cosine to stars, and then they would take their zenith measurements, right, and the star would never be where they expected it to be. That's all they've ever done. The only reason that they got the globe is because their zenith measurements never lined up. But that's because what we see is apparent to us. It's always apparent.
Interesting.
I was going to say too, like in terms of like the idea of diverging plumb lines versus plumb lines being parallel. In some ways, this reminds me of that, because like even like the one on the right there, the globe one, like that would be the Pike's Peak would be angled off, like the plumb line for Pike's Peak would be diverged from the observer. And I know it's not exactly that because these are angles, so it's not exactly plums, but in a way that it kind of makes me think of the difference. Whereas of course over the planar, you have everything aligned, in verticals and horizontals, whereas the globe has that added sort of angular tilt away because of the radius and the curvature and all that then makes those plumb lines essentially diverge, which then means the angle of the mountain is going to be at a different angle, and therefore the timing would be different.
Yeah. Well, what's really cool about the divergent plumb lines is that's where they took their zenith measurements of the stars, where they expected it to be based off of a cosine to it based off of an elevation where they were previously. And then when they took their zenith measurement, they were like, oh dude, how do we get this star to be in the center of the telescope directly? And that difference is that's where the globe came from. That's where I need to tilt my plumb bob this much to make it in the center, because I'm not actually level because there's a gravitational anomaly here. Isn't that crazy, dude?
Wild. Actually pretty wild.
That is.
They're
It's
only a few
based so
arc
much
seconds,
off of
those
that.
things, aren't they?
What'd you say, Deza?
What's that?
Only a
Big
few
dog?
arc seconds, those gravitational anomalies typically.
Oh no,
Enough to
there's
impact the overall shape measurement.
well, that's explicitly where it comes from, because all the spherical excess is only what is it, Shane? That it comes out to be 0.000 something over 1/8. It's not even significant. It literally comes from these little deviations, which is where they say Earth gets its eccentricity. There we go. That deviation from the perfect sphere or whatever, from a perfect circle, is based off of them taking zenith measurements and them never being in the center of the theodolite.
Well, the bigger the distance, the bigger the more the spherical excess they can manufacture, right?
That too, but we were talking specifically about the Zenny measurements, I think. But in the south, right, isn't there what was it, up to a degree or something in corrections, Shane?
Oh, I forget. I don't know. Deza, do you know?
The Australia one was nuts.
As I said, that she specifically had a number where it wasn't.
It was only a couple arc seconds.
It's a degree.
Or whatever.
That's a lot.
It was very significant. Let me see if I can well, I don't care right now because we're doing celestial theodolite, but it's on Shane's thing under 69 miles per, or no, it's under what's it under? Doesn't matter.
By the way, before we end this, I just saw Mr. Learns. Have you been paying attention to the celestial theodolite presentation, or you just pop in? I would love to hear your take on it.
I came here about 5 minutes ago.
What up, young Matthew?
Hey, how's it going?
Going good, man. I haven't spoken with you in quite a while.
Yeah, likewise. Obviously.
Would you like the data?
May I interest you in a celestial theodolite, sir?
I don't know if I'd have much use for it. I live in LA County, and it's hard to see stars here.
Oh, well, no worries.
It's buy 3 get 33 free.
we're having a special right now.
Yeah, the interesting thing about celestial navigation is it uses a linear equation that you multiply the zenith distance times 60 nautical miles.
Works for all angles.
No, but for real, Matthew, are you familiar with this? Because he's doing a presentation right now, but this
Yeah,
I'll
go
follow
ahead.
up. But are you familiar with this though? If you see a screen share, are you familiar with the?
Yeah, I'm looking at the screen share now, and I recognize this image. I haven't looked deeply into it because I know it's been talked about some recently. Did somebody do this recently?
Nice. Yeah, actually, earlier tonight, some new data just came in, and we got some new occlusions to add to it. But I'll give you a quick rundown of it if you don't mind. If you got a minute.
Love to.
Okay, so basically, my boy Mike here was taking theodolite measurements of this mountain peak, and he found first that it gave the flat Earth measurement, and he was like, "Whoa, no way!" Right? And then he measured it with a more accurate modern theodolite, and it gave a measurement that was more closer to the globe. But in between there, he was looking into refraction and different things, and basically using a theodolite to measure a mountain and confirm or falsify the globe is going to be impossible because there's numerous refraction coefficients that you could slap in there to turn any observation into a planar observation, essentially, right? If you're going to make the radius bigger. So what he came up with was calculating what the raw elevation angle of this mountain would be by taking the difference in elevation from the observer at his location, which in this instance happens to be 50.7 kilometers away. But I got the numbers changed on this one for a different spot, but we're doing the old one. So anyway, he calculates that distance and angle there, which comes out with the difference in elevation, which comes out to be 2 degrees and 31 arc minutes. So meaning this is just plain trig to what this mountain peak would be for an observer 50.7 kilometers away. And then when you do the same for the glob, doing the arc sine of the distance and the radius, you get 2 degrees and 4 arc minutes. And then you add, well, you wouldn't technically do this, right? You would calculate it a little differently. So you would do terrestrial refraction, but doing it this method, right? You add 15 arc minutes for the celestial refraction, which puts you at the 219, which is what the glob predicts it would be. Or you could do the 2 pi method, which gets you to, I think it's 217, and then you add 2 arc minutes for terrestrial refraction, which puts you up to 219. So either way you slice it, we're here at 219 now. So we have 2 different angles here. So we're going to go into stellarium now, and we're going to enter the coordinates for this mountain peak, which happens to be Pike's Peak in this example. And we're going to set our elevation in stellarium. Oops, let me bring this up.
Yeah, I've used Stellarium. I know how you can set the location and angle or elevation.
Okay, perfect. Yeah. So you just set it to that elevation. So we calculated it at 231. So we have the star here at that angle, and then we go out and we wait until that time, right? That this star is going to intersect at our relevant angle. And then when it gets occluded, it's either going to correspond to the time that's at 230 or if it's at the time that's at 219. So all that's been measured so far are times that correspond to the raw flat Earth elevation angles that are calculated. Oh, and when we go into stellarium, we're turning refraction off. So we're just referencing the true position of the star, not the visual position. So when the true position intersects with that mountain at that angle, right, for an observer 50.7 kilometers away, the star is no longer visible at that exact time. Does that make sense?
Yeah, it sounds like it matters whether you think refraction is happening or not. Then, right?
Ooh, so specifically, we're not dealing with refraction because what we're dealing with is when the star isn't visible anymore. And I think we can all agree that if it's not visible, it's not being refracted up anymore, right?
Right.
Yeah. So that's the significant portion of this. So it's only going to be physically occulted at a time that corresponds to an angle of 231, or a later time that corresponds to 219 because the star has to get lower. So I think if you translate arc seconds to actual seconds, it's a 1-to-4 ratio. So one arc minute is 4 seconds. So yeah, that's going to create quite a timing difference there.
Yeah. Okay.
And, yeah. And then 1 second, we have to correct something for John, who keeps telling this awesome story about Alan literally booted me out of ether cosmology mid-sentence for maintaining that the angular position of a theodolite does not depend on the object of the operator he thinks it's pointing at. Well, there was a conversation about the equivalence of that air and how it was derived, right? And the agreement was, oh yeah, it is equivalent. It is proper. You did at those distances. It is 8 inches per mile square. I agree. And then you were like, but no, I don't agree anymore. Now that locks me into my position, and I don't deal well with doublespeak, John. So you can do that in the chat the whole night and keep doing that and like play a victim. But you know why you got banned? Why would you? Why do you include a sad story about it?
To be fair, it was pretty wild because it was Eric, who is a Glober, who basically was trying to steelman what Dr. Mike was supposing, which is basically that the farther away you are from said object that you're viewing with the Theodolite, the scaling error will basically compound, after a certain amount of distance. And then Eric basically was saying, yeah, I mean, it's the same ratio. And then John said, yeah, I agree. And then when Dr. Mike explained it, he said, I don't agree. But it was literally the same explanation. And then I don't know, he just flipped out. I was there for that.
Well, okay, so maybe I do need to set the record straight. What there was in that room was a constant.
It's on video.
There was that's fine. Play the video. There was a constant confusion between the difference between an angle becoming a larger vertical distance as the distance to the object increases. That's true. That's what happens when the angle itself doesn't change. And Mike Heffron's correction was based on the idea that the angular correction increases with distance. That's just not true.
You got it on video? It's great.
Yeah, Dave uploaded it, and I also have.
Does anybody else not care?
Yeah, it also super doesn't matter, but it's so annoying to just read that every day.
We could just post it and then let people watch it.
Yeah, I get the link from Dave. But anyway, Celestial Theody.
Yeah, but so Matthew, essentially what you're doing with the Celestial Theodolite, you're using the peak of a mountain as your crosshair, essentially. So you calculate a distance between you and the mountain peak, calculate the elevation angle, basically, just using plane trig. And then you wait, right? You're looking at the mountain peak. You're waiting for a star to get occluded by that mountain peak. Then you look up in Stellarium at that exact same time, and you basically see what star was occluded, put the observer on the mountain peak in Stellarium, and lo and behold, it matches the plane geometry prediction angle every time. And I can say every time now because there's what? How many observations have you done now, Dr. Mike? Probably up 40. Maybe
it's
less.
Probably 40 or 50 on 7 different peaks so far.
So it's just a coincidence.
That's a lot. That's like at least
right with a small nearby hill.
Oh yeah.
Can I ask a quick question about the precision of the timing? How accurate do you need to be? Because I'm going to try and do this right. I just want to know how precise the time needs to be and what the impact is of
plus or minus 1 second.
Errors.
Plus or minus 1 second, and 1 arc minute translates to 4 seconds.
Yeah, that's pretty accurate.
It's pretty wild, Matthew. If you want the paperwork, I can
star, or does it
post it for you again if you want to see this graph.
It's interesting observations. Yeah, I'll see that.
Well, I know you're a math lad, so I figured you appreciate this. I'm going to tag you in it.
Matthew, do you know of or have you heard of any rebuttals for this? Or is this your first time hearing it?
I don't know of any rebuttals to this, no.
There you go, Matthew. I tagged you.
If anyone comes up with a Glober answer that doesn't involve bringing the observer back to the original house and try to get refraction into the mountain, if anyone comes up with a solution not involving that, I'd be very interested to hear it.
I mean, at this point, we kind of know why they have to do that. All right. Anybody else have any questions or just, even clarifying questions to understand what Dr. Mike has presented?
No, but maybe could you guys summarize it really quickly for the room before you guys wrap it up?
Absolutely. So what you can do to show that the Earth measures flat with respect to the stars is you can calculate the angle to a mountain peak relative to your distance by taking the difference in elevation between you and said mountain peak. That'll give you, well, you can just use the spreadsheet too. And then with that, that'll get you your difference in altitude. Yeah, and you can calculate your angle off of that. So you'll get in this instance, you get 2 degrees, 31 arc minutes. And then you take that calculated angle, then you go into Stellarium, you enter the coordinates that'll put you on top of that mountain peak, and then you set your crosshair little reticle to that exact angle that you calculated earlier, and then you play out the night sky for however many days that it takes until a star intersects your crosshair at that angle. Once you have that star getting intersected at that crosshair, you wait until that day occurs, and when that happens, you
See if it matches up.
yeah, you just wait and see when you just wait and see until you can't see the star anymore. And if that time corresponds to the time that matched the angle in Stellarium, then what you've shown is that there is a physical obstruction at that calculated elevation angle relative to your distance away that is now physically obstructing a celestial body from your vision. And that's showing that angle relationship would only be due to the intersection of the quote-unquote true position of the star, because that's what we're using in reference to Stellarium for our intersection point on the peak of the mountain, and you can infer that the angle from that, in order for that to line up geometrically speaking, right, has to be 231 as well. Although when you look through a theodolite and make this measurement, you'll never measure 231, right? It'll always be like about 219. It'll always be what the quote-unquote globe predicts, but that's just due to optical compression and refraction, the actual optical compression and refraction, right? But the timing shows us that the actual physical elevation angle between you and that mountain is 231. Otherwise, that star would get blocked at a different time. It would take longer for the star to get blocked because the star would have to get lower in the horizon, which takes more time. And remember, arc seconds translates to 4 real seconds. So the difference here is going to be noticeable by 12 to 18 seconds in time, depending on your angle, right? But that's all you need to do to make the measurement, and you could do this anywhere that you have the corresponding peak to make the obstruction. So why wouldn't it be important to take the measure of that?
Alan, was
Yeah.
there a predicted angle? Like, did you guys predict something and then make a measurement?
Did we predict something? We predicted that a specific time that a star would get occluded, and then we
Can you
verified
do it without Stellarium?
Can we do it without Stellarium? Sure, we could do it with a nautical almanac. The nautical almanac will tell us the time that it'll be there relative to that position on the mountain. The Stellarium is the nautical almanac, so all we're referencing is a position.
That's a good point. We should have to do it straight from the nautical almanac, shouldn't we?
Sure.
What you'd have to do, though, if you actually wanted to use the nautical almanac, because I don't think they have records of stars below, 20 degrees, right? Something like that?
No, I'm pretty sure they. I'm pretty sure.
Or is it up to 10? Is it 10 degrees? I know there's a certain limit.
I'm not sure. Yeah,
they've got a correction
below 10,
table.
the refraction is such a problem that it's not useful for celestial navigation. So
yeah, they've got massive correction tables for like the lower angles.
So I'm keen to see what this thing does
I'm not
above
sure
20
what they go
degrees,
to,
above 10 degrees. I think it'd be interesting.
Do you understand though that like refraction is already not an issue though? So it's like already interesting, just based on that.
Is any glober willing to entertain a scenario where refraction isn't there? Just for 1 second and entertain it.
No, all we can do so far is link the 1 kilometer
that's
difference.
the key thing, right? Because if you went and measured these angles physically with a theodolite, they wouldn't be what was predicted by the geometry you've drawn, right? You know that's a fact.
But that's what's in contention,
so
though.
you have something going on.
Are you guys just unable to entertain a hypothetical? Like if we said, "What if you don't have breakfast today?" You couldn't answer that, right?
That's what's in contention, right? We're saying that when you look through a theodolite and take these measures, Jesus Christ. When we say that we're taking a measurement with a theodolite, that optical measurement is going to be subject to curved visual space or refraction, right? That's the difference here. So when we do it with this method, there's no refraction because we can't see the star anymore. That's the significance of it. You mean?
And they're getting pissed. They're gonna be pissed once they find out you took their refraction away. They're gonna be freaking so upset.
There you go. Videos in the I don't know. I genuinely don't know why you're like, bring it. That's so funny. Anyway, there's the video from that.
Oh, I was looking for that. Nice.
Like, did you think there was going to be a different outcome? Anyway,
one just general thought I had on all this, like what general equipment do you kind of recommend or consider in terms of for when the star is occluded?
Ooh, great question. Great question, Mike. What do you recommend using? You've been the one that's been doing it the most. What's your current setup?
What are you rocking?
What's the bare minimum, dude? Show us your gear, bro.
Where's your rig?
Show us your celestial theodolite. All right, he's hard AFK. Yeah, so you just need something that's able to take time-lapse footage at night, preferably in 1 second intervals, and have it be synced to GPS time or like your phone or something like that, because your phone's already synced to GPS time. So as long as you're on that with timestamps, should be good to go. That's basically all you need.
How about the new P1100?
If it can film stuff at night, I don't know what it's like to film stars at night with a decent camera. I've only ever used a cheap cell phone camera, and it looks horrible.
Yeah, I
I couldn't imagine using that as evidence. But if you have something that actually films the stuff at night and can see at night like that, then yeah. Like,
Was that a
I think
joke?
I'll show you guys
Is there a
like the
P1100
bare
or is that a
minimum,
joke?
kind of. I guess show you what
There-
Mike's setup was.
There is a P1100. Yeah, it just came out. Yeah, it's like the newest one.
Nice.
How expensive is it?
So here,
I think it's like 1500.
Oh yeah. Ooh, did you show the moon one to them yet? Look
Not
at
yet,
this
but
one.
that's
This
how your
one's
boy's going
so
to.
cool. This is Omega 39 Aquarii, Omega 1 with the moon. It's right underneath the moon, and it's so sick looking.
Yeah, so check this out.
Look at that. Boom. Occlusion time.
And then somebody messaged me the other day, and they said they got the moon being occluded by it. The entire moon at Pikes Peak being occluded.
That's what's up.
See, this is.
That
Oh
thing
yeah,
is
could
so
this be
cool.
done with like the moon?
So it could, but I feel like you would have to, you just have to wait until it's not visible anymore.
Or you have to
Same,
denote
same with all the other stuff.
or you'd have to almost denote like a part of the moon, like the first time it first hits it or something, because yeah, it's so much larger.
Did you see this,
It's the
Gio?
angular side.
Here,
No, that's
rewind
the
it.
first time I've seen that. That's awesome.
Rewind it.
Yeah.
Rewind it for the boys. That's so cool looking. Look at this. Look at the star right underneath it. Boom.
Ooh,
Occluded.
nice.
So good looking.
Yeah, that's a clean one. That's a good one.
Yeah, and then we just watch them fall into the mountain peak all
Mountain
night at one specific time, guys. At one specific time.
To me, it doesn't look like the mountain's jumping up and down that refraction dictates it would, right? It looks like it's just chilling, and stars are going behind the mountain. Just saying. It looks pretty stable there.
So this fully replaces boats over the curve, with stars over the flat mountain.
It's so cool
I-
looking too.
If
Dr.
I
Mike,
zoom
thank
in,
you,
I
bro.
can bring the star back.
Your work is much appreciated, Dr. Mike. Let me just say.
If you look really close at some of the videos I've taken during bad weather days, you will see the mountain peak moving up and down a little bit.
Right.
But therein is the whole reason for this method in the first place, so that you can eliminate refraction by timing when the star disappears, so that you know refraction is no longer in play, and then look up what the angle was at the time that happened.
Exactly. Genius.
Wait, is this the guy that came up with it?
Yeah.
Here, right now?
Yeah, it's Dr. Mike.
Oh,
Yep, it was me.
nice to have you here, man. Awesome.
It is I. I am here.
It is I.
Is he a freaking coffee drinker?
He's otherwise
Just
known
bring
as
him
the
back a
Pyrenees.
coffee, man.
He's
You in
otherwise
America?
known as the.
Oh, sorry.
No, you're good. I was gonna say he's otherwise known as the Great Pyrenees King.
God. Well, why's
Right,
that?
Dr. Mike? Because he takes care of like 12 giant Pyrenees dogs.
Oh.
Do we have anybody doing this in the southern hemisphere?
Ooh, good question.
If
How
there
about
was one.
How about in Antarctica? Can we get this? Can we get one in
Or,
Antarctica?
I mean, just as far south as, I don't know. That's kind of my question.
No, that is an interesting point. Yeah, doing it in the south of the equator.
I mean, if I were to posit that the counter rotation of the sun, for example, was like some kind of refracted phenomena or something, I would need to know that the phenomena that we see in the sky can be falsified one way or another. So if we could, this works in the north, I wonder how it works in the south, or if it checks out the same.
I wouldn't see why it wouldn't, because it's based really more upon the geometry of the ground and the sky relationship, unless the geometry is different there. But a good amount of people live in Australia, so
As long as the timing's the same in terms of like when it gets occluded, it would be a counter rotation. But I think Jesse was gonna do another mountain peak and stare at the east and time a star getting revealed as it rises from the east. I mean, it's the same thing. It's all about the timing, really. The timing is what confirms the angle.
Well
What if
said.
what if you could do this at like Canigou, at like 300 mile? If you could get
Oh
it
yeah,
that far.
cop that 300 piece.
Yeah, and again, the emphasis on the distance away from the peak that you're viewing. The longer the distance, the bigger the difference between globe math and flat Earth math is apparent. That's the point, right? Like the farther you're, like in the globe paradigm, the farther away you are from something, the more globe slant is supposed to be there. So
yeah, the
using,
tilt.
right?
Yeah,
Exactly.
we've always talked
using
about
a
the
mile
tilt.
wouldn't work. Like a mile, like a small hill nearby, that doesn't work. It's not analogous. You can't tell the difference.
Right, yeah, that whole thing John said. I was almost going to say, like, as a joke to John, it's like, John, what you're saying, that'd be like trying to measure Earth curve with a 12-inch ruler.
Exactly.
Dude, it was slightly better than last week when Dazzle was like, "Can I do it from my backyard using my house?"
Oh my God, yeah, 3 meters away or whatever he said.
Like,
we're getting
yeah.
better. We got to a mile. We got to a mile.
Okay, if this works, how come I can't see China from my backyard?
Yeah, it's crazy. All right. Any other questions or clarifying questions or refutations? I won't hold my breath for those, but whatever.
How it helps to determine the shape of the ground. Still don't understand.
No worries, lad. If anyone wants to do this observation and they live near some mountain peaks and they need help coming up with what stars would be being occluded at specific times or whatever, just email me. My email is allanspaceaudits@gmail.com, and I'll help you figure out all the necessary information for you to make your observation. We would love to add your data to the table, to the ever-growing database of celestial occlusions.
So, Alan,
All right.
then I hit the space bar, then type in audits.
No. Alan Space Audits. Oh, yes.
Nice
yes.
joke.
Nice one, Jeremy. All right, lads. We'll go ahead and wrap this up.
Thanks,
We'll be back in a
Gio.
few. Thanks,
Appreciate
Gio.
Yeah. Cheers. That was great.
And then Alan. Oh yeah. So tune in tomorrow where hopefully it goes down. Alan's gonna present the celestial theodolite to Jaren.
Really?
that
Like
would
on
be
a live stream? Doing it live?
Yeah, he's not gonna come into Discord apparently. He doesn't do Discord. Shocker. But yeah, tomorrow for the Ether Round Table. I look forward to it.
That's interesting. Are you guys gonna like keep it like academic professional, or are you guys gonna like try to debate mode him?
It's just Alan and Jaren, and he's just gonna present it.
Oh, I got you. Sounds exciting.
But I was gonna say too, like, you know, like we've talked about the tilt, you know, like things would tilt away on a globe. But there's always a challenge because, like, you know, to get something to where you could actually measure that, you know, because like that's often the rebuttal, which is a decent rebuttal on the globe. You know, they'll sort of say, well, you know, the actual amount that it's tilting is so negligible. And when you do the calculations, like in terms of like a building, it is pretty minimal, you know, like in terms of how far away that is, like the amount of tilt. But this is a different scenario because it's using a mountain, which is obviously, you know, much taller than a building, and then it's using the sky, which is much further away as well. So you're just getting this completely different ratio to where now essentially you're able to measure the tilt. Or if the tilt was there, you would be able to, not necessarily directly, but just because you're expanding out the tool so much longer to where you have a mountain and then the star, so you're able to kind of, it's like getting leverage.
And the ruler.
Yeah. To be able to actually measure that. And I'm not saying it's actually measuring tilt, but yeah, it is measuring. I mean, it would if it was a globe, I suppose, it would be measuring that the amount at which that mountain would be displaced and curving away over the spherical surface if it was, you know, curving.
Yeah, Gio, we wouldn't be here if it was as simple as that. If it was just curving away. Like, don't you wish sometimes that the globe was real? You know what I mean? Like,
Not really. I'm happy it's not. I'm like infinitely happy. It's just awesome because we actually have a chance that humanity does because the way it is now. That's not the only reason, but that's just like one thought. But no, I never really. What you're saying? You want it to be one? Or I mean,
like I'm saying, like it would be so much like, oh, all right, Earth's not flat. Let me move on with my life.
Oh, you
Like,
mean
like Star Wars?
Like like to have this kind of conversation repeatedly over and over with people, you know, it's great. It's just crazy to me how some people react to it. Like when you just take like a third party look at everything, and it's like, okay, it's where's the evidence for the globe? I'm still waiting. You guys have been waiting for what? 10 years, 8 years, 5 years, 6 years? It's been like a year and some change for me, and I'm still like shocked by some of the reactions that people have, and it's just like, what's going on? But anyway, I digress.
Well, are you saying like sometimes thinking that it would be because it's like it's such an intense like situation to be in a way of like, do you mean like in terms of that, like just almost like it's like because it is like it could almost be seen as like, oh my gosh, it's like a bad dream, you know? It's like the whole there's like this massive deception going on about where we live. Like it could be interpreted that way. Do you mean like from that perspective and just like
Yeah, dude, it's crazy.
just to go back to just like, oh, it's a ball and we just discovered it and everything's, you know, well, there's just a little corruption but nothing too major, and you know, we're instead of like this thing which is so like systemically corrupt.
Yeah, I mean, you know, you start off at one level of disbelief, like, oh, the government wouldn't lie to you. Now it's like not only are they lying to you, but they're trying to kill you at every turn. Like literally. But again, I'm just saying it's been a wild journey personally, just to see the different minds, you know, come to the same conclusions, and some come to the different, like, it's how some people come to different conclusions. I try to logically follow them and like put myself in their shoes, but I can't because I've already seen too much. And it's sad. It's sad. Some people just don't want to accept the knowledge, you know, that it's empirical, you know, like it's, I don't know. It's just weird.
Yeah, when you think of the globe as like a massive, like just like propaganda campaign, when I think of it in that sense, you know, like because there's so many things that are pushed as propaganda that are just so false, and we know we're just like it's like just popping a balloon, you know, just pop. Now the globe one's obviously a lot bigger than that, but when you think about all of the like compartmentalization and you know top-down authority through the whole chain as to where the actual data is coming from when it comes to like what they call outer space and things like that, and you kind of see the whole like chain of command of it all, and it's like, you know, could they have the data stacked in terms of that, the compartmentalization, and then in addition the propagandized kind of, you know, machinery as it were to put that into the world, like with the printing press and everything, you know, and then of course now to where they can like push these huge campaigns the way that they have, which is really like even coming out of World War II. I mean, how many people really even believed the globe is the question, because it seems like they had to do all the satellites and moon landing and all that stuff to really like get it ingrained into people's mindsets as well. So yeah, it's pretty intense.
I do have to ask myself sometimes, it's like, all right, now that I have the information, what do I do with it?
Well, here's a question. If it's about the Earth, do you feel like the spirit of the Earth has the answer to that? I guess like even the idea of like being guided by Mother Earth kind of thing, and like the connected to the truth and Earth, would it be connected to that? Because the Earth is like, there's the idea it's like massively powerful, like you know, way beyond any entity upon it. So I just wondered if you like.
I don't necessarily have the whole Mother Earth Gaia kind of feel, just to be honest with you. I'm more of an external god type situation. You know, I'm a Christian. So I can't really, I mean, I get what you're saying, but I don't think it's the Earth fighting back. That kind of goes into like the whole climate change, you know, humans are horrible, we're overpopulated kind of narrative, and I just don't really agree with that.
I'll hear you on that. Well, do you think the Earth is a being?
No.
To use that term? Like an organism? Or like that it has a consciousness to it? Like the Earth itself?
No. I wouldn't necessarily say that. But then again, I don't know. Maybe.
Yeah, I would say most Christians would say no for that.
Yeah.
All right, the straight line is stars taking over because I feel like you took
something dead cannot create
at me
something living.
there, and it's not.
All right,
Jeremy,
never mind.
Well, Jeremy, you're kind of breaking up. What were you saying?
Yeah, you guys.
When you guys are done with this, it's on.
I said nothing dead can create something living. So if we came from the Earth, it would imply that the Earth has some sort of life force or consciousness to it, regardless if there's an external God.
Or we didn't come from the Earth. That would be the other implication or other possibility.
Yeah, that's a little silly, though.
Yeah, Michael, Matthew, perhaps you're aware of the law of biogenesis?